Okay, going to be working a problem here from Chapter 10, Section 3. It's going to be number 18. And I already worked this out on video. And this problem came from the section on dot product. And the way I worked it out on the video was very, very lengthy. And, well, I was trying to use the dot product because that's what the section was covering to do the problem. 10-3, problem number 18. And what it did is it gave you a vector. Okay, so I think the video I did the vector 3, 4. So let's just take that vector 3, 4. And it says, all right, you've got this vector 3, 4. So we'll just put it in standard position here from the origin out. We've got this vector 3, 4. And what we want to do is find two vectors that make an angle of 60 degrees with this. So there are two vectors, one that's 60 degrees this way, one that's 60 degrees that way, but the two vectors we want to find have to be unit vectors, which means if we imagine having the unit circle here, circle radius 1 there, that the vectors we have that we're looking for have to be 60 degrees this way. So I'm just going to put 60 degrees this way. That's one vector. And then the other vector is 60 degrees the other way, which is some other vector. We need to find those two vectors. Now, the way I did it again on the other video was very time consuming. So I just want to show you a different approach. And the reason why I did it the long way was because, again, we were in the dot product section. I wanted to use the dot product, but the algebra got really messy. So instead, what I'm going to do here is just use my knowledge of trigonometry to answer the same question. So imagine you have a right triangle here. We know this side is 4 and this side is 3. So the distance from here to here is 3. Distance from here to here is 4. And so let me just find this angle. I'm going to call it theta. And to do that, I just use my knowledge of trig again, which says that tangent theta should be my opposite side over over the adjacent side, so 4/3, and that means theta has to be arctangent of 4/3. And I'm just going to get on my calculator. I'm going to go in degree mode on my calculator. Make sure I'm in the right mode. I am in degree mode, and I'm going to take arctangent of 4/3. And I get an angle, theta, that is approximately 53.13 degrees. Okay, so this becomes really simple now because to find these two vectors, I just need to add 60 degrees to that, and that would give me one angle. I'll call it for vector 1, the first vector that I'm going to look for, which would be this one, V1. I'm going to add 60 degrees to that. So for V1, its angle, which I'll call theta 1, is equal to 113.13 degrees. And then for vector 2, which is this one, vector 2, this one has an angle theta sub 2 equal. So what I'll do is I'll take the 53.13 and I will subtract 60 from it. And so when we do that, we get negative 6.87 degrees. I'm approximating. So that gives us our two angles of those vectors. Now we're supposed to find the actual components of the vectors. So what I'm going to do is I'm going to kind of zoom in here on this first vector V1. That vector V1, like this, okay? Here's our axis. We know that this angle right here is 113.13 degrees. And so what we want to know are basically the x and y coordinates of this point. And to do that, I can use my relationships that I learned again in pre-cal that say that if you have an arbitrary circle, not a unit circle, arbitrary circle of radius r and an angle here of theta, that the x coordinate is r cosine theta and the y coordinate is r sine theta. And I know my radius here. I know my radius because this has to be a unit vector. I know that the circle I'm on here has a radius of 1. Okay, so from here to here is 1. I know the angle. So I can find the x and y coordinates. So all I'm going to do is do 1 times cosine of 113 degrees and 1 times sine of 113 degrees. And that'll give me my x and y coordinates. So cosine of 113.13. So for vector 1, the vector is negative 0.3928. And then to get the y component, I do sine. So sine of 113.13, and I get 0.9196, something like that. And then to get V2, I'm going to do the exact same thing, but instead of using 113.13, I'm going to use negative 6.87. So cosine of negative 6.87 is going to give me 0.9928, and then sine of negative 6.87 gives me negative 0.1196. So these are the two vectors that form an angle of 60 degrees with this given vector and have a length of 1. So that's definitely the easier way to go about that problem.